morning. Today we are continuing with the topic of P block element. Till now, the portion has been equalized for both the batch, cyan batch, as well as for the Santa Cruz batch. I'm continuing with it. P block elements. We are starting with allotropy. Allotropy. What is allotropy? Can anybody knows the meaning of allotropy? Anybody knows the meaning of allotropy? Same element in different physical form. Example, phosphorus. Phosphorus exists as a red phosphorus. It exists as a white phosphorus. And it also exists as black phosphorus. Formulas are same, but different forms are there. Carbon. Carbon exists as amorphous. Carbon exists as crystalline. In crystalline form also, it is in a form of diamond. It is in a form of graphite. So these are all different allotropes of element, and this property is called as a allotropy. We are going to see allotropy of group 16, allotropy of group 16. Allotropes are mostly shown by group 16. In group 16, elements, the first element is oxygen. Oxygen has two allotropes. And those are oxygen, and second one is ozone. So oxygen has two allotropes, that means in different form, oxygen and ozone. Sulfur, the second element, has many allotropes, many allotropes. One is rhombic sulfur, monoclinic sulfur, plastic sulfur, milk of sulfur, colloidal sulfur. But your textbook has given only two, that is rhombic and monoclinic sulfur. These are the main allotropes of sulfur. Sulfur, as you know, they are octatomic. The molecules are made up of 8 atoms. So both are 8 atoms. So rhombic and monoclinic, these are allotropes of sulfur, and both these allotropes are non-metallic. Okay. Then comes Oxo sulfur, selenium. Selenium. Selenium has two forms, two allotropes. One is a red metallic allotrope, so non-metallic allotrope. And second is gray metallic allotrope. Then comes the tellurium. Tellurium again has two forms, two allotropes. One is crystalline, other is amorphous. Polonium being radioactive, it has got two allotropes. One is alpha and second one is beta. So we have seen the common allotropes of oxygen, sulfur, selenium, tellurium, and polonium. And there are, sulfur has many, but only two are discussed in your textbook as per your syllabus. Rhombic and monoclinic. We'll just emphasize on allotropes of sulfur. The most stable allotrope of sulfur is rhombic. Why we say stable? All other allotropes on standing convert into rhombic sulfur. So all allotropes of sulfur are finally converted into rhombic sulfur. Therefore, we call that rhombic sulfur is the most stable sulfur form, more stable form of allotrope. Rhombic and monoclinic. First of all, it is pale yellow in color. And this is bright yellow in color. Secondly, It has got octarhombic, also orthorhombic, crystal structure, and this has got needle-shaped structure. Needle-shaped monoclinic sulfur, needle-shaped crystal. Third, it is stable below 369 Kelvin. It is stable above 369 Kelvin. See. That means below 369, all sulfur will be in the form of rhombic sulfur. And above 369, it is in the monoclinic sulfur. Its density is little higher. Rhombic sulfur, it is 2.069, and your density is 1.989. Fifth one, it is prepared by evaporation of rolled sulfur solution in carbon disulfide. That means rolled sulfur solution. Rolled sulfur is dissolved in carbon disulfide. Carbon disulfide is a solvent, and that solution on evaporation will give you rhombic sulfur, where this is obtained by melting rhombic sulfur followed by cooling gives needle-shaped crystal, needle-shaped crystals of monoclinic sulfur. So this is a allotropy of sulfur. Main emphasize a bit on rhombic and monoclinic sulfur. Next, we are going to see oxyacids.
Sir,
हाँ,
sir, reaction with halogens or metals बाकी है.
कौन सा?
Reaction towards halogens or metals है ना वो.
अच्छा, reactivity towards halogens and reactivity towards metal. Okay, I will
हाँ
do it.
sir, वही
Okay, I will
बाकी
do it. Doesn't matter. This is for science branch, I think so.
Yes sir.
Okay. Now we'll do oxoacids. Oxoacids. What are oxoacids? First of all, what are acids? Acids are the substance which give hydrogen ion. Acid containing oxygen are called oxoacids. Example, HCl is an acid, hydrochloric acid. But we can get HOCl, hypochlorous acid. Hypochlorous acid. Here there is an oxygen. Sulfuric acid. right? It is also an oxyacid because it contains oxygen along with H. Okay. So we are going to see different types of oxyacids of sulfur and group 16 and group 17. So oxoacids of sulfur, there are many. First is sulfurous acid. Sulfurous acid formula H2SO3. Structure sulfur OH OH SO. Okay. Is a structure. It is a dibasic acid. Dibasic acid means it gives you two H ions on dissociation. And it has a lone pair of electrons. It has a lone pair of electrons. Second acid, thiosulfuric acid. Thiosulfurous acid. Thiosulfurous acid. Structure S OH H OH double bond S. Formula of thiosulfuric H2 H2O3. See the difference. Difference of one S and difference of one oxygen. Two O2, sorry. It is not O. O3, O2. This is also dibasic acid. Dibasic acid. And it has a lone pair of electrons. Okay. Next. Sulfuric acid. Sulfuric acid. H2SO4. Formula. Sulfuric acid. It is also called oil of winter, oil of vitriol, vitriol oil. Green vitriol oil or vitriol oil. Structure OH S OH O O is a dibasic acid. This is third. Fourth, thiosulfuric acid. Formula H2 S2 O3. Structure S double bond O, OH, OH. Thiosulfuric acid is also dibasic acid. So basicity depends upon number of OH group. जितना OH group होगा उतना वो H ion देगा. So it is dibasic acid. Next, fifth, pyrosulfuric acid. Pyrosulfuric acid. H2, S2, H2, H2, O7. See the structure of sulfuric acid. उसी structure से बनता है ये. H, O, S, double bond O, double bond O, single bond O, single bond, double bond O, double bond O, O, H. Compare sulfuric acid and pyrosulfuric acid. Compare the structure. Pyrosulfuric acid is obtained from sulfuric acid by losing water molecule. दो सल्फ्यूरिक एसिड कंबाइन करेंगे और वाटर मॉलिक्यूल निकलेगा तो हमें पायरोसल्फ्यूरिक एसिड बनता है. Two sulfuric acid combined by removal of water molecule. See that, compare that. बीच में देखो OH है, इधर एक मॉलिक्यूल का OH दूसरे मॉलिक्यूल से H, and these two molecules are joined by oxygen. This is pyrosulfuric acid. Six. Peroxydisulfuric acid. Peroxydisulfuric acid. Similar to same ऊपर वाला. थोड़ा सा डिफरेंस. O, O, S, O, O, OH. Peroxy, peroxy, दो oxygen. This is also called the Marshall acid. Next, peroxymonosulfuric acid. Peroxymonosulfuric acid. Marshall acid का formula H2 H2O8. Peroxymonosulfuric acid, H2SO5. See here. SO, SO, O, OH, OH. Peroxymonosulfuric acid, one extra oxygen, peroxy. ऊपर वाला peroxy disulfuric acid और नीचे वाला monosulfuric acid. 8. Thiosulfuric acid. Thiosulfuric acid. Thio का मतलब there will be SS bond. SS bond. ये देखो S, double bond S, double bond O, OH, OH. It is H2, S2, O3. Okay. So these are different oxyacids of sulfur. Peroxyacid, monosulfuric acid is also called as Carrot's acid. Oh. Now we'll see oxyacids of
सर
हाँ जी
सर सब डाइबेसिक होगा ना, सबके पास OH ग्रुप है
हाँ सब डायबेसिक होगा.
सब ना. ओके.
Number of basicity depends upon number of OH group. Okay. Now oxyacids of halogen. Oxo acids of halogens. Halogen form 4 types of oxyacids. Halogen form 4 types of oxyacids. One is hypohalous acid. दूसरा है halous acid. Then a halic acid. And third is perhalic acid. Take for example fluorine. Fluorine from HOF. It is called as hypofluorous acid. Halous acid. Nil. Fluorine only form one type of acid, that is hypofluorous acid. Chlorine. Chlorine form 4 types of acids. HOCl, hypochlorous acid. Then Hallous acid, this is chlorous acid, halic acid, HClO3, chloric acid, chloric acid, and HClO4, perchloric acid. All of them are monobasic acid. इसमें एक OH है, एक हाइड्रोजन मीन्स एक OH है. All are monobasic acid. Bromine. Bromine form HOBr, hypobromous acid. It doesn't form bromous acid, but it forms HBrO3, bromic acid. And it forms HBrO4, hyperbromic acid. Then iodine, HOI, hypoiodized as hypoiodized acid. It forms HiO3, iodic acid. And third is HiO4, periodic acid. If you write the structure of each of them, you'll get there is one OH group. One OH group, that means that it will dissociate to give you one H ion. So all are monobasic acid. Except in fluorine acid, Oxyacids of fluorine, all other ClBrI, the oxidation state will be positive. In hypofluorous acid, fluorine will have -1. As we know that fluorine has only -1 oxidation state because it has got absence of d orbital. While in other hypohallous acid, chlorine, bromine, iodine will have positive oxidation state. So that was the oxyacids of halogen. Now we'll move on to compounds of group 16, group 17, group 18. We'll be seeing the compounds of group 16 and group 8. So it is first group 16 ka. We'll see first oxygen and compounds of oxygen. Oxygen and compounds of oxygen. First, we'll see oxygen. We'll see the preparation of oxygen. Then we'll see the chemical, physical and the chemical properties of oxygen. And third, uses of oxygen. Okay. Let's see first preparation. Laboratory method of preparation of oxygen. How oxygen is prepared. Preparation of oxygen in laboratory. Potassium chlorate on heating in presence of MnO2 as a catalyst gives oxygen gas. Oxygen gas. Okay. So this is first method, laboratory method. Potassium chlorate का formula KClO3. This on heating in presence of MnO2, you get KCl plus oxygen. KCl plus oxygen. Okay. Okay. So this was the first method, or very common method of preparation of oxygen in laboratory by heating potassium chlorate in presence of MnO2 as a catalyst, you get oxygen. Second method, by thermal decomposition. By thermal decomposition of metal oxides. There are some metal oxides which are very unstable. Some metal oxides very unstable. They on just heating decompose and give you metal and oxygen. Example, silver oxide. We heat them, it dissociates, it decomposes and give you silver plus oxygen. Mercury oxide will give you silver, mercury plus oxygen. Lead peroxide. Lead peroxide. On heating will give you lead oxide plus oxygen. Then hydrogen peroxide. Hydrogen peroxide. On heating in presence of MnO2 as a catalyst, you get water plus oxygen. So these are common methods of preparation of oxygen in laboratory. Okay. Oxygen is also prepared by electrolysis of acidified water. That means water on acidification or acidified water. That means water containing small amount of acid on when you pass electricity, you get oxygen and hydrogen in volume 2:1. And this is called as electrolysis. You get oxygen at anode and you get hydrogen at cathode. Okay, in volume 2:1. Okay. Next, industrial method of preparing oxygen. Oxygen industrially is prepared from air. You know, air contains about 20% of oxygen. 20% of the air is oxygen. So air on distillation, air on fraction distillation will give you oxygen. And this is one of the industrial method of preparing. So first, air is purified from dust and from that air, dust-free air, we are removing carbon dioxide, we are removing water vapor. From dust-free air, we remove carbon dioxide and water vapor, we get, and this air on cooling and compression. give liquid air. Liquid air, and this liquid air mostly contain nitrogen and oxygen. Because air का main constituent क्या है? Nitrogen 79%, oxygen 20%, and 1% other gases, including inert gases, carbon dioxide, water vapor, dust. Carbon dioxide कितना है? 0.03. So first the air is free from the dust, carbon dioxide is removed, water is removed. Carbon dioxide is removed by using potassium hydroxide. Air is passed to potassium hydroxide. Carbon dioxide combined with potassium hydroxide, and it is removed. Water is removed by passing through anhydrous copper sulfate. Water is removed. And this air on cooling and compression, उसको high pressure कब करेंगे तो air is converted into liquid air, and this liquid air on fractional distillation. The fractional distillation करते air का, by higher and higher temperature you get oxygen and nitrogen at different temperature. So this is how oxygen is prepared on large scale from the air. Now, physical properties of oxygen. Oxygen has color? No. Oxygen is colorless. Oxygen has odor? No. Odorless. Oxygen has got no color, no odorless. It is soluble in water. Completely? No. It is sparingly soluble in water. Oxygen is sparingly soluble in water. Sparingly का मतलब कितना? How much oxygen is soluble in water? About 30 ml. In water, around 30 ml of oxygen is soluble in a liter of water. But even then, the marine animals are alive in the water, though there is less quantity of oxygen. 30 ml per liter, there will be only 30 ml of oxygen in water. And that also, some of this oxygen is utilized by the organic substance present in the water, that is the impurities. If there are any impurities are present in the water, then the further oxygen is deteriorated, the amount of oxygen is decreased. Okay? If any oil is added by accident, further oxygen is reduced. पहले से ऑक्सीजन कम है एयर में, लेकिन कुछ और impurities होगी, then it will be further the quantity of oxygen will be reduced. In a pure form, oxygen has only 30 ml of water contain only 30 ml of oxygen per liter of water. Oxygen has 3 isotopes. That all you know. Which are those 3 isotopes? O816, O817, O818. 3 isotopes of oxygen have same atomic number but different mass. Oxygen liquefies at 90K. 90K का मतलब कितना? 273 minus 90. At minus 183 degrees Celsius, oxygen is in a liquid form. And oxygen solidified at 55 Kelvin. 55 Kelvin का मतलब 273 minus 55. 8, 1 at minus 208 degrees Celsius, you get a solid oxygen. Oxygen is paramagnetic, that we know it, because that is one of the property. Anomalous behavior oxygen. Oxygen is paramagnetic. Now, let us see the chemical properties of oxygen. Chemical properties of oxygen. First, reaction with metal. Oxygen react with metal and form oxides, metal oxide. Except gold, platinum, it doesn't react with oxygen. We take aluminium. Aluminium react with oxygen and form aluminium oxide. Calcium react with oxygen. So formula ये गलत लिखा मैं. This formula is wrong. Calcium oxide. Next, reaction with non-metal. carbon plus oxygen, carbon dioxide. Phosphorus plus oxygen, phosphorus pentoxide. So these are the reactions. Reaction of oxygen with some compound. Zinc sulfide react with oxygen and form zinc oxide plus sulfur dioxide. Methane, combustion of methane. Methane will form carbon dioxide plus water. Hydrochloric acid plus oxygen. In presence of cuprous chloride, you'll get chlorine plus water. Look. Uses of oxygen. Uses of oxygen. Use for respiration. Respiration. To sustain life. Without oxygen, we cannot survive. It is used to produce oxyacetylene flame. Oxyacetylene flame. For welding and cutting. For welding and cutting of metals. What is oxyacetylene flame? A flame which is used, which contain two gases, oxygen and acetylene. Dono gas. We see sometime welders are using two cylinders. एक में acetylene होगा, दूसरे में oxygen होगा. And both are connected to the flame. And the temperature of the flame is around more than 3000 degrees Celsius, which is used for cutting the metal or welding or joining the metal. Third, it is used for combustion of fuel. Combustion of fuel in car, in fuels, right? In rockets. Fourth, it is used in hospital. high altitude by mountaineers. Okay. So this was the uses of oxygen. Now we'll see oxides, water oxides, and type of oxides. Water oxides and type of oxide. Water oxide and types of oxide. A binary compound of element of an element with oxygen is called an oxide. Is called an oxide. A binary compound of an element with oxygen is called an oxide. A binary compound of an element with oxygen is called an oxide. Oxides are of four types. Oxides are of four types. Acidic oxide, basic oxide, amphoteric oxide, and fourth one, neutral oxide. Acidic oxide, basic oxide, and neutral oxide. What are acidic oxide? We'll see each of them with one example and reaction. एक एक देखेंगे. Oxides. Acidic oxide. An oxide which dissolve in water, to give an acid. Is called acidic oxide. या उसका दूसरा डेफिनेशन क्या है? An oxide which reacts with a base to give a salt is called acidic oxide. जो ऑक्साइड बेस के साथ रिएक्ट करता है एंड सॉल्ट फॉर्म करता है इज कॉल्ड एज अ एसिडिक ऑक्साइड. Let's see. Sulfur dioxide react with water and form sulfuric acid. Okay. Is acidic oxide because it reacts with water and form an acid, sulfurous acid. Sulfur dioxide react with base and form salt. And water. Okay. So it is an acidic oxide. This is salt. This is base. This is acidic oxide. Generally, oxides of non-metals are acidic oxide. Generally, oxides of non-metal are acidic oxide. So this was first type of oxide. Now let us see the second type of oxide. What is that? Basic oxide. Oxide which reacts with water and form a base is called as basic oxide. We form a base is called basic oxide. Yeah, or an oxide which reacts with an oxide which react with an acid to form salt is called acidic oxide. Sorry, a basic oxide. Very basic oxide. Example, sodium oxide react with water. You get sodium hydroxide. Calcium oxide react with water. We get calcium hydroxide. Or sodium oxide react with acid. You get salt and water. Sodium oxide react with water to form salt is called as basic oxide. Okay. Amphoteric oxide. Acidic oxide react with base. Basic oxide react with acid. Amphoteric oxide, which react with a base as well as with acid to give salt, is called as amphoteric oxide. An oxide which reacts with base, which reacts with a base as well as with an acid to give salt, is called an amphoteric oxide. Is called as an amphoteric oxide. Example: aluminium oxide, zinc oxide. Aluminium oxide react with acid and form salt and water. It is reacting with acid. Aluminium oxide reacting with the base and form sodium aluminate plus water. So this is an amphoteric oxide. And the fourth one is neutral oxide. Which neither react with acid nor react with base. The oxide which neither reacts with an acid or base to form water, to form either react with acid or are called neutral acid, are called neutral oxide. They are not reacting with either with acid or with base. कौन से वो ऑक्साइड? Carbon monoxide, nitric oxide, nitrous oxide. These are all neutral oxides. Okay. So we have seen oxygen, type of oxides. Now we'll see one compound of oxygen, that is ozone. ozone. We'll see what is ozone, preparation of ozone, physical properties of ozone, chemical properties of ozone, and structure of ozone, uses of ozone. Ozone, it is an allotrope of oxygen. ऑक्सीजन के दो एलोट्रॉप्स होते हैं, एक ऑक्सीजन एंड दूसरा ओजोन. It is formed in the upper atmosphere of atmosphere in which the ultraviolet rays or ultraviolet ray, light rays dissociates oxygen molecule. So O, UV light, it will form oxygen and oxygen. ये dissociation होता है. And this oxygen combined with oxygen atom combined with oxygen molecule and you get ozone.